Hello test takers and welcome back to Exam Prep Solutions, and today we're going to be going over critical depth and specific energy in a channel. If you haven't already, you should subscribe to the channel. We have a lot of great videos coming on the FE Civil exam. Also, we have a free guide, how to solve any FE exam problem in 5 steps. You can find that for free in the description box down below. Just tell us where to send it. Anyways, let's take a look at this problem here. Find the critical depth of a rectangular channel given the following characteristics: as a width of 11 feet, a stream velocity of 5 feet per second, and the height of this channel is 3 feet. So we're going to need to find the critical depth, and the critical depth is defined as the depth in a channel at some sort of minimum specific energy. And we'll have additional problems on specific energy, but for right now, we're just going to find the critical depth. So you should have your FE handbook open and you should be searching for the equation right now because that's what you're going to need to do on the test. Go ahead, try and solve it without my solution, and then we're going to go for it here. So note that it says for rectangular channels, we want to find the critical depth for a rectangular channel. Well, we have an equation right here. Y sub c equals lowercase q, keep that in mind, squared divided by g, and that's raised to the 1/3 power. So how do we find all these different factors here? We know g is gravity, that's going to be pretty straightforward, but let's see what this lowercase q value is equal to. Looks like this lowercase q is equal to unit discharge. Okay, it keeps resetting to the uppercase q, but you guys get the idea. Is q divided by b. So it's going to be the flow rate over the channel width. Notice we don't have a flow provided to us, right? So how do we find flow? Well, q equals v times a, right? Velocity times area. That is one of the formulas that we know from our studies in water resources. So the velocity was 5 feet per second. And the area of the channel, we got a channel width of 11 times 3. So it looks like our flow rate is going to be 165 CFS for this problem here. So 165 is q. But then we have lowercase q equals 165, because that was the flow rate that we found, divided by the channel width again. So we're dividing it by 11 now. And then we get 15 to be our unit discharge in this case. So now we can insert this into the critical depth equation. So we take 15 and square it, divided by g, which is 32.2 for English units. That's what we're operating in here. That's all raised to the 1/3 power. It looks like here we get a result of 1.9118. That's going to be the critical depth in feet of our channel. If we look here at the available answers, it's pretty clear we should go with A in this case. The answer is A there. The key is recognizing what kind of channel you're given, finding that unit discharge given what we have available. We use the continuity equation to solve for Q, and then we plugged it into the equation, make sure we use the right value for G as well. So that's how to find the critical depth in a rectangular channel. If you have any questions on that problem, you can leave it in a comment down below, or if you have any problem requests, you can also leave that in a comment down below. Anyways, thanks for watching, and we'll see you guys next time.